Okay, so here we're asked to find the values of theta in the range between 0 and 360 degrees, satisfying this equation here. Alright, so we're going to get a set of results. We're going to have to draw a trig graph to get all the results between 0 and 360. But you'll notice here in the C4 paper with trigonometry, you have double angles. It pops up here, right? Double angles. And you just need to remember, okay, what is sine 2 theta? Okay, using our double angle result, it's going to be 2 sine theta cos theta. Okay, that's what sine 2 theta is. If you can't remember it, as I said, you work it out from how we've done before. Okay, the methods we've used before. But that's what it is. Okay, and obviously then it says it's equal to cos theta. And what I would do then is, with equations, I try to get everything to one side. Okay, that's the approach here. Get everything to one side. So I'll rewrite this as 2 sine theta cos theta, and take the cos theta over, of course, then get it all to one side, so we've got it equal to 0. Okay, and then we're meant to solve this. Now, often we get like a quadratic out, okay, which we could factorize with 2 brackets. Now, in this case, right, it's a bit simpler because we haven't got anything sort of squared, you know, like a cos squared plus cos plus a number, and you have 2 brackets. Here, we've got a combination, we've got sine and coses, but what I want you to notice is cos is common in both terms, okay? So we're actually going to factorize out cos theta, okay? And the mistake some people make is they think, oh, because cos goes into both terms, I can just divide through by cos, okay? And it will disappear. But if you do that, you're going to end up losing results, okay, from this. So don't go about it that way, right? You shouldn't be dividing in that case, because you lose results. So the best way is look at these two terms and think, well, cos is a common factor, so I'm going to factorize it. I'm going to have cos theta outside my bracket, and then I'm going to have a bracket then, and I'm going to put it equals to 0, and I'm going to ask myself then, well, what do I times by cos theta to get 2 sine theta cos theta? Well, that's just going to be 2 sine theta. And then what do I times by cos theta to get minus cos theta? And that's going to be minus 1, isn't it? Okay, so all I've done is I factorized out the cos theta. Okay, and then you need to appreciate, well, if I've got 2 terms times together and equals 0, in this case I've got the cos theta times this bracket equals 0. One of them, of course, has got to be 0. So we say like cos theta equals 0, or 2 sine theta minus 1 equals 0. Okay, now we can go about solving it. All right, cos theta equals 0 is really simple to work out. In fact, I can draw like a mini graph for that. I don't need to go over the top and draw a huge graph. Okay, I could just draw a little graph just to appreciate where cos theta is equal to 0. Okay, you don't even need to use your calculator neither. You could just draw your cos graph. Now remember, cos 0 is 1. Okay, cos 90 is 0. Cos 180 is minus 1. Cos 270 is 0, and then cos 360 is 1. Okay, so you know, and check them on your calculator, you know, if you're not sure, but you can draw your graph, right, and you can see then where cos theta is equal to 0. It's there and there, so theta will be 90 degrees or 270. Okay, now when it comes to solving this, you need to obviously take that minus 1 over, so it becomes a plus 1, and then take the 2 over and divide by 2. So you've got sine theta equals a half, and of course then to get theta, we'll do sine to the minus 1 over half, and you do use your calculator on that, and that actually comes out to be 30 degrees then, in degree mode, of course. Okay, and that's what comes out. So when it comes then to drawing your sine graph, okay, we need to be a bit more careful with this then, right? So with a sine graph, you know, what I tend to do is, I tend to, every, say, 2 centimeters represents 90 degrees, okay? So I got 2 there, 2 there, 2 there, 2 there, something like that, okay? And I only need to go to 360, so put 90 there, 180 here, 270 there, 360, and we put 1 up here. Let's just try and measure this out so it's accurate, so it's the 2 centimeters height of 1, and then 2 centimeters down, minus 1. Okay, so then sine 0 is 1, sine 0 is 0, isn't it? Okay, I'm going to confuse you with my cos graph. Alright, so sine 0 is 0. Okay, use your calculator. Sine 90 is 1. Sine 180 is 0. Sine 270 is minus 1. Sine 360 is 0. So when we draw our sine graph, okay, we have that. Of course, we're interested in the results where it's equal to 30 degrees, and of course it's a half, so half is about there, isn't it? So draw a line across. Okay, get a half. So we've got 30 degrees here, and we've got that angle there. So we just need to use symmetry then to appreciate what that angle is going to be. So we've got an angle of 30 degrees, which is found there. And to get that angle, of course, you've got to sort of go backwards, haven't you, from 180. So it's going to be 180 minus 30 degrees. So it'll be 150 degrees. Okay? So our overall results will be 30 degrees. That one there, which is, or that one up there, which is 90 degrees, is going order. This one here, which is 150 degrees. So that one's done, that one's done, that one's done, and then the last one, 270 degrees.